Now we're going to look at rectangular form of a vector. Rectangular form is just another way to write vectors. We are going to want to be very fluent at converting between rectangular form and component form. Fortunately, that's very easy to do. So first, what is rectangular form? Well, the most simple way to get rectangular form of a vector is if I have some vector v where the initial location is at the point 0, 0, or the origin, and the terminal location is at the point A, B, so just some other point in space. Then we can represent this as V equals AI plus BJ. So in component form, this would be V equals A comma B. So that's what I mean there. That it's just a different way to write it. Where here in the rectangular form we have this I and J component. Think of this as your X direction and this is your Y direction. Just like here, this is the X direction and the Y direction. So I is just a more specific way of telling you that that is the X direction or that is the horizontal direction, and J is the vertical direction if you want. Where A and B are called scalar components of V because they are telling you how far to go in the horizontal direction and how far to go in the vertical direction. So that's why we're calling them scalar components. A is the horizontal component, B is the vertical component. The vector sum AI plus BJ is called a linear combination of the vectors I and J. The magnitude of vector v is going to be the square root of a squared plus b squared. Again, that's just our distance formula. The direction of vector v. So this is a new part. The direction is an angle. It's always an angle measured counterclockwise from the positive side of the x-axis. It's usually in degrees. So real quick, the positive measured counterclockwise from the positive side of the x-axis. That's just how we measure things in trig in general, you know, when we think about our unit circle. So that's what we're doing here as well. So how do we find that direction angle? Well, using trig. I know that if b is the vertical component and a is the horizontal component, then the tangent of theta is b over a. Draw a picture and that should be pretty easy to think about. Okay, so let's do an example. Sketch the vector v equals negative 3i plus 4j and find its magnitude. Well, if I have negative 3i, that means I go left 3, 4j, I go up 4. So the vector is this vector. That's the vector. What's the magnitude? Magnitude of v, and I know this without doing any work, but I'm going to go ahead and do the work just for fun, is negative 3 squared plus 4 squared, square root of that. Magnitude of v is going to be 5. It's a 3, 4, 5 triangle. Any questions on that? Okay, good. A little quiet again, as usual. Keep in mind, so this would be the angle theta. All right, so if I have tangent of theta equals negative 3 over 4, we are going to have to use a little bit of knowledge of our trig. If we use the inverse function on our calculator, remember the inverse function is only going to restrict us to quadrants 1 and quadrants 4. So we have to use the concept of reference angles and things like that so that we can get the positive angle going counterclockwise between the positive side of the x-axis and the actual vector. Next thing, so taking the rectangular form a step further, so the initial definition, I said that the initial point of the vector is always at 0, 0, but we know that vectors can be anywhere in space. So what if it's not at 0, 0? Well, we can still write the rectangular form of the vector. So if I have some point P1, which is the coordinates x1, y1, and that's the initial point on the vector, and then the terminal point P2 is the coordinates x2, y2. I know that vector v in rectangular form would be x2 minus x1 I plus y2 minus y1 j. when adding and subtracting vectors in component form, in rectangular form, and I keep confusing it because it's doing the same thing as if it was in component form. The only difference is here we have the i's and the j's, so we just add the corresponding I scalars and we add the corresponding b scalars to get that v plus w would be a1 plus a2i plus b1 plus b2j. Subtraction is the same thing. Subtract the corresponding I scalars and the corresponding B scalars to get A1 minus A2I plus B1 minus B2J. I apologize that I'm going through this a little bit quickly, but I really think that a lot of it is pretty straightforward, and it's also written down for you. So go ahead and try this example though. If V is 5i plus 4j and W is 6i minus 9j, I want you to find V plus W and V minus W. Pause the video, unpause when you're ready to check. All right, so hopefully you got that V plus W is going to be 11i minus 5j, and V minus W is going to be negative I plus 13j. And you can see our work here, just adding the components and subtracting the components. Keep in mind that initially we're always going to put a plus between the I and j, but in this case, since the j term came out to be negative, I changed that to a minus. Scalar multiplication, again, also very straightforward. If I have some vector v equals ai plus bj, k is any real number, then the scalar multiplication of vector v and scalar k is going to be k times v, which is kai plus kbj. So you just multiply each scalar component of the vector by the scalar. So go ahead and try this. If v equals 2i minus 3j, find 5v and negative 3v. Pause the video, unpause when you're ready to check. So here we get 5v is 10i minus 15j, and negative 3v is negative 6i plus 9j. Oh, let's circle that. All right, so here are just some other properties of vectors that I'm just going to kind of, again, talk through. They are already on your sheet. So here I have vectors u, v, and w. Then the following properties have to be true. For vector addition, u plus v equals v plus u. The quantity u plus v and then plus w has to equal the quantity v plus the quantity u plus w. U plus 0 is going to equal 0 plus u, which is u. U plus negative u is going to equal negative u plus u, which is 0. Now same things, but now we also have c and d are scalars. So c times d times u is going to equal c times d times u. C times u plus v is cv plus cu. C plus d times u is cu plus du. 1 times u is u. 0 times u is 0. The magnitude of cv is the absolute value of c times the magnitude of v. Okay, so vectors again, directed line segments. Understand the various ways in which we can represent a vector. So we briefly saw vector form. We've worked a lot with component form, and then now we did rectangular form. Understand the direction of a vector comes from trigonometry, and also understand the basic operations of vectors: addition, subtraction, multiplication, how those relate to vectors.